Hello, everyone. Thanks for coming over. A lot of people here. So how's everyone doing?
Yeah, let's go.
ML Conversations meetup. How many of you guys here first time? Right, cool. Wow, thanks for showing up. And how many of you guys here been like at least one time? Two? More than two? All right, cool, like returning people. So my name is Vlad Ermin. I work in data science and I've been in the field for quite some time. And here, along with Ian, who works at also like around like machine learning, ML engineering here at Capital One. I'll give like a quick like few words about like what this meetup is about and how it started and like what you should expect. We have like quite intense lineup for today, so I don't want to spend much time. But originally, we've started just as our small informal group of people in machine learning, data science, AI, ML, chatting over the drink in a bar not far away from here about some challenges, experience, common situation. Then it kind of evolved into our small presentations in someone's apartment. And fast forward a year, we got a space, and now we have this wonderful space for almost 2 years now we've been hosting. And the core idea behind AI/ML Conversations is building a community and a group of people who are passionate and want to share their knowledge, experience working in the field. So the core idea in the center of our community is you guys, and particularly those of you who submitted to us to be our speakers. So we have this QR code and we present it every time in the beginning. This is call for speaker. If you passionate about what you're doing or genuinely interested and want to share, or your colleagues kind of think about you that you can't shut up about like talking ML, please fill out this form. Even if you never present it, we'll help you out through the process, or reach out to me, Ian, we'll help you out through your questions. So especially for those of you who are in the back, this is the link for the same slides. So their presentation and the slides of all our speakers will be available afterwards. So this is the link for the deck, so you can follow along. And we also have our YouTube channel where we recently started publishing our recorded meetups, including this one. It will be recorded and we publish it on our YouTube. So if you want to rewatch some parts or you want to share it, subscribe to our YouTube channel. Capital One.
Yeah. Capital One. That's me. Hello. Whoop. Let's try this non-feedback thing by pointing the mic away from the speakers and see how that goes.
It looks like
nice.
this is a...
Yeah, I got to watch out for those guys. Hello, welcome. My name is Ian. I'm here on behalf of Capital One, who is here to sponsor this event. You are standing here in the realms of the Capital One office. I'm curious, could anyone raise their hands here if you also currently work at Capital One? All right, we got some hands in the audience. Excellent. If you want to join these people among our ranks, we are hiring. And so if you are interested in getting a little like bump through this referral pipeline, you can let me know. We got this bit.ly/AIML refer. And you could also talk to me afterwards to get more details about this process. And that's about it on the Capital One side. So I'll bring it on back to Vlad.
Thanks, Ian. I heard Capital One do a lot of cool stuff around AI/ML, so that's a really good opportunity. A couple of more housekeeping. We have a Discord. That's a good place for feedback if you want to suggest a talk or any particular idea. This is the place where you can reach out to us, to organizers, to our host team, and to the community as well. This is a QR code for Supermoments. Whoever of you guys come here from Supermoments, this is your QR code. If you don't know what I'm talking about, doesn't matter. After the event, we're also going to go to the bar following the old tradition of this event and the gathering. So if you're still going to have some time and want to stick around for a little bit, this is a place we're going to meet around like 8 p.m. So here's the QR code. That concludes the official part. And before I pass the mic to our first speaker, I want to kind of set the stage a little bit about the theme. I've been thinking about coding agents and LLMs and like want to dedicate the full talk to bring people who've been working very closely with LLMs and AI-assisted agents for coding in particular, but also for the general stuff, because it feels that this tool being kind of thrown out in the business without kind of for test out right in production, and nobody kind of really know how exact do and do nots, and we kind of figuring out this on the fly. And that's why I want to kind of use this stage of AI/ML conversation meetup to have more like a conversation and also get a feedback from, or maybe like stories or anecdotes from your experience about what worked, what you found out to be working or not working, and generally collect some like best practices or kind of stitch together kind of some like a knowledge of how should we think about applying agents, LLMs in particular, into the kind of pipelines, like business and technical pipelines, such that it actually helps and not kind of blow things up. So we're going to have two people presenting. Alex Petrov, he is a founder and CEO of xmemory.ai. He done some great research around building a memory for AI agents. And the second speaker is Konstantin Visna. He has experience working as a staff software engineer at Google, and he applied LLMs and like agents for one of his projects, and he also be sharing some of his best practices. So, and after that, we'll hold a Q&A and a discussion session where we'll have like more like a conversation. And I'll encourage you guys, if you have some strong opinion, experience, and you not agree with what we're saying, to share it with us. So with that being said, I'm welcoming Alex Petrov. Thank you.
Hi, everyone. My name is Alex. I'm here from London. I live in London. So I'm a little bit jet lagged now. It's a little late in London. I'm going to be talking about AI memory architectures. And before I start, just can you raise your hand if you've built your agent for anything? How many builders we have in this room? Quite a lot. How many of you had experience building agents and struggling with memory? Compaction, forgetfulness, hallucinations, pretty much everyone who raised the hand in the first. Okay, good. So then we have the relevant audience for this. When we say memory, different people understand different things. So the white ones is not what we're going to be talking about. So we're not going to be talking about parametric memory, which is basically weights inside the LLMs. We're not going to be talking about latent memory, which is adjustments, key value cache in the beginning or at the end of LLM processing, and in context memory as well. Like if you just adjust the prompts inside, it's not memory, it's basically context management. It's a different topic. What we're talking about is external memory. So it's persistent store that exists outside of the model. And yeah, it's written at runtime. So we're going to be talking about external persistent storage memories, which is quite a crowded space, I must say. This picture doesn't help anyone. It's from 2025 survey on memory in the age of AI agents. It's probably outdated because every single day we have a new company releasing new memory solution, a state-of-the-art, 100% Lacoma benchmark and all this kind of stuff. Just so you understand, half of these logos is just research. It's not practical or applicable to any real agent. Another half is basically split between 5 typical architectures that I'm going to be covering. If you follow the news, we have an unusual guest in AI memory space. Just today or yesterday, Mila Jovovich announced that she started a startup in memory space. And they also reached 100 in Lacoma benchmark, which anyone who knows Lacoma benchmark knows that it's not possible because it's crazy dirty. And you cannot reach 100 even if you're a human. So yeah, I didn't think that I will kind of compete with my legend and hero from the past in memory space so quickly. So we have 5 typical architectures for external memory. The first one is probably the one that most of you played with, is plain files or transcript and summary files, MD files. Examples of solutions in this space are LangGraph and Llama Index, and basically you just store the data in files. Semantic extraction is anything that is trying to summarize or compact text and then store in some vector database, sometimes with some graph on top, but graph and temporal is a separate category. Then there is agent managed hybrid. A good example is Leta. It's basically when you store a lot of files, let's say in a file system, and you ask agent to traverse the file system, find the right file, and then extract information from the right file. Then graph and temporal. This is the direction of kind of more structure in memory. A good example is Zep or Graffiti. It's good at storing temporal data. Relations and time, some entities. I don't know if anyone played with, can you raise your hand if you tried any graph storage for your agents? If you ever built like ontology of entities or objects? Nobody. Okay, that's a good sign, I guess. And the last one is schema. So basically trying to store information in traditional relational databases in some sort of schema. So this example is us. I don't know any other solution on the market that is doing exactly what we do in terms of memory storage. So if you think about it, every architecture trades coverage for control. So the more coverage in terms of questions you can ask to memory, the more generic the memory is, the less control you have. So on the left, you have transcript and summary, no structure at all. It's just files. You do compaction, you do some reorganization of this, or you just simply store the whole history of your chats and try to find information there. You have zero control over what's stored in there, and you don't see exactly what's stored. You can read through, but it's not easy to query or do something automation like on top of that. And the schema is on the far right, so not really good coverage in terms of like if you don't have a specific field in your schema and specific object inside the memory, you just forget this information. But you have a lot of control, so you can inspect data, you can update data, you can build analytics dashboards on top of it, you can automate some stuff, you can do triggers on top of these kind of objects, and anytime your agent writes into a specific table, a specific field, you can trigger some action, like marketing automation for CRM systems, for instance. And you get more trust because you can actually see what's going on inside the memory. It's not just like millions and millions lines of text that you don't see. If I try to put all the solutions on the map, like structured, less structured, governed, less governed on the left, traditional graph RAG solutions are on the left top, and pure vector RAG is on the bottom. So we are there on the right, as you see. You can, I don't know, maybe you know some names here like Mem0, Super Memory. So that's basically the map. Did you guys have any experience with any of the names here on this chart? Did you try any of the solutions? Okay. Probably you will try xmemory after this talk, I hope so. So it's not only about control and structure, it's about functional gaps. If you have unstructured memory, you don't actually get aggregation, state, relational, or negative and exclusion queries. You cannot ask your chat history what is the current status of something, because in order to ask this question, you will need to read the whole chat history and find the most latest update of specific status, which is quite time consuming and it's actually kind of expensive. Relational as well, you cannot do aggregation, like list all of something happened somewhere. So it's not a semantic search. It's not something like you have semantic closeness that you can easily retrieve from vector database, a specific sentence, and it will answer your question. You need to do some reasoning or calculation, whatever you call it, on top of your storage in order to answer these kind of questions. And structure actually brings that because it stores information in specific buckets, and you can query those buckets using SQL, or you can query using like text to SQL and ask natural language questions as well. But any architecture has points of loss, and this is basically a traditional RAG solution. What you do, you have a lot of text on the left, you do compression, you lose some information in compression. Now it's called compaction, if I'm not mistaken. People use different words for this, but the point is that this compaction is loss of information. Then you do embeddings, is basically assign this blob of text a specific point in vector space, which is also loss of information because how you assign it is LLM decides that, and it's not precise process. Then you do retrieval. Retrieval is when you have your query, you know the coordinate of your query in this vector space, and you draw basically a sphere around it, and you retrieve everything that is inside this sphere. It's just, again, not precise retrieval. It's just like you guess the radius of the sphere. Then you do some magic. Some people do re-ranking on top of that, and then you put it into prompt. And again, you try to rely on LLM to decide what information from this prompt to actually use in response. So it's also kind of loss. In case of structure, so this is the most unstructured, I should say, memory is just storing text. If you try to extract structure, then you have text on the left again, and then you do object extraction, and you have this kind of schema in the middle, and then you do retrieval using TaskSQL from this structure. The problem is this also has some losses. Obviously, extraction is not an easy task, and I will spend a couple of minutes talking about that. The reason why it's not an easy task is because we operate a different level of entropy. You guys know what entropy is? Well, the measure of mass. So entropy level of language is different from the entropy level of any structured system. And normalized data entropy level, you can think of third normal form of database structure, something like that. It's much more structured than language, so you need to kind of drop between the levels, and it associated with some losses. I wrote 90%, but in reality, it's much less than 90%. It's what everybody on the market claims as 90% accuracy. Think about it, if you do these kind of jumps, and in the bottom you see user task, then LLM, then call to API, system of record, or any database, really. If you do these jumps like 100 times in your workflow, you multiply 0.9 100 times, and you get a dramatic drop in accuracy. And this is the numbers, basically. So a lot of people I speak to in AI world, they say that, yeah, well, structured output is reliable. We should just let the LLMs decide and help us with this task. This is the most recent measurements. We just did it yesterday in our lab. Field level accuracy, 96%, sounds good. But if you ask it to extract a specific object, which has like name, surname, age, or something else, then accuracy drops to 76, 80%. Gemini, if you have anyone from DeepMind or Google here, you just guys don't follow JSON schema. I don't know why. If you start following JSON schema, your numbers are going to go up. OpenAI is leading, but if you see the variance in the numbers is much, much higher than in Anthropic models. And yeah, multi-object is when you need to extract something more complex, just one object. Example is, these ones actually were calculated with the data set from CleanLab, and it's extraction of details from insurance data sets. Insurance data set, one insurance record contains like person who is claiming, the object that was insured, some details. It's multiple objects. And if you extract multiple objects, you get 30%. So 1/3 of all the questions you ask LLM to extract and write into any external system, only 1/3 is correct. It's just surprising. Most people think that it's like 90-something. So the most frequent question I'm being asked about why xmemory is not just an MCP over Postgres, because MCP operates SQL and we operate natural language. And the difference is that you need to do all of this stuff that is listed in this central section. You do need to do extraction properly from your text in order to formulate the SQL record. Then you need to do validation and type enforcement, which is not an easy task as well. And deduplication, stateful updates, relations, observability tools to see how it actually works and what it does. Not just logs, some visual observability so you can debug and test your agents. Schema creation and evolution is not an easy task as well. And yeah, we have a sync write queue, which helps you to do it much faster than if you wanted to directly write into Postgres or any relational database. The point of this slide is actually, last week was a nice article, the white paper by Stanford researchers about meta harness. And it proves that harness, which is the code around LLM queries, is equally important to LLM quality. So best models, you want to achieve good results. And vice versa, even with small models and relatively, outdated or on device and fast models, if you have a good harness code, you can achieve much better results. And you can think of xmemory as state-of-the-art harness for any relational database access. This is one of the ways of thinking about us. So one real-life experiment, just to give you a bit more numbers. We like this experiment. This is expense tracking experiment. We need to track shared expenses using AI agent. Let's say we all, as a team, we go to a restaurant, we spend some money. Not everyone is actually present every single time, so different group of people. Someone pays for everybody, and then we need to split somehow. And if you use Splitwise, there is a nice app. So basically, it was inspired by the app Splitwise. And then we need to answer simple questions like who owes whom, how much, and who participated in which transaction, something like that. The idea was we generate schema from description. It's not that we design the schema and code something. We don't code anything. It's just an access to xmemory. Then we create an instance of xmemory, record 50 expenses in natural language. We just say, hey, me and Vlad went to a restaurant and spent $50 together. That's it. That's the record. 50 of such records, and then we check the balance against the ground truth and do it 25 times just to make sure that we have enough. So we compare ourselves to one-shot LLM. You just put all these 50 records in one prompt. This is what a lot of people do. This is prompt, it's a kind of context management memory. We also add setup and query inside this prompt, so we tell LLM as much as we can about the task. And the second comparison was around Markdown files. This is the most popular way of storing information, Markdown files. We had actually two architectures for Markdown file structure. We'll talk about it in a minute. And then we try to use frontier chats like OpenChat, Claude, or on your mobile or in a desktop, and try to talk about these expenses with them. And here are the numbers. Yep. Quite depressing. So Markdown agentic memory number one is when you try to actually store every single expense because you don't know the questions. You might need all of the expenses. If you try to do that, you just get 12% accuracy. Then, okay, we decided let's change that. Let's not ask it to store all the expenses. Let's ask it to store the balances. So only we have the person and the balance. Let it update the balance every single time you write. We expected 99% accuracy. It was 40%. Then single LLM call API is just 24%. You give all the information in the prompt, and you hope that context window is big enough for it to reason, and it doesn't. Like those are for both OpenAI and Claude and Anthropic models, the frontier ones. And then the chat applications. It's 92, it looks good, but it's not accessible for you as a developer to use the chat app. APIs are completely different from chats. When you chat, it actually does a lot of harness itself. So it's basically a metric of how good the harness behind ChatGPT and Claude app is. It's 92%. And what we saw is that we don't see exactly what ChatGPT is doing, but Claude was writing scripts to analyze the history of the conversation. It was basically Python scripts that it was writing to calculate balances, which is insane, and only 92% accuracy. So when you write into xmemory, you get 98. And the reason it's not 100 is because it's automatically generated schemas. If you put a little bit of effort and you kind of review the schema yourself and see where you can improve it, you easily reach 100%. So that's the difference. And it's not about mathematical calculations, right? It's because what we store in our memory is not the balance. We don't try to calculate the balance. It's not mathematics. It's just storing the facts, who participated, when, and how much they paid. That's the core of the memory that we store. All of the calculations are made on top when you do requests. So it's applicable to any kind of memory, any use case. Schema is not the problem. Some people say, well, I don't know my schema. If you don't know your schema, you probably know your questions. The questions that your business needs to ask the memory solution, the questions your agents are dealing with. If you formulate the questions, we have schema generation agent, and it generates nice schemas and answering questions with 98+% accuracy, which is, I think, fantastic. So what else on top of functionality and everything else? Those are the 5 architectures I highlighted in the beginning: transcript, semantic, hybrid, graph, and schema, and you get different benefits. And I like the read latency, for instance, right? Hybrid is crazy slow. Or token consumption, like hybrid, semantic, and transcript, they consume much more tokens than we do. If you think about it, if you write into structure, you actually consume tokens on write path, but you don't really consume much on read path, because you don't need to read all the information. You do precise query, and then you retrieve it, and it's less tokens. So yeah, choose solution for your task. If you don't know the questions, if you want to store absolutely everything, if you can sacrifice observability, stability, and analytics, of course, you should start using text, and it's kind of first choice. It's safe. But if you do want some observability, analytics, and everything else, just think about how your memory is structured. When I say observability, this is just a screenshot. You see the request at top on the top. It says Alice Smith no longer works at Global Corp. She has joined Initech, a consulting company. So extractor, you see here, it's extracted 2 companies, Globex Corp and Tech Consulting, and then the employee. It extracted the relation, and it actually calculated it against the current state of the database. So there is a diff engine that updates the object and updates the relations. Sorry, say again? Can I? Yeah, so it's slow. It should, yeah, here we go. So this is the extraction step. This is what we extracted from the text. And then, and this is the calculation of the diff you need to apply on top of existing memory records in the database. But if you guys are interested, we have a demo that we can show you in real life. Yeah, if anyone knows the context of this lady, we need a good brand ambassador, because we're competing with the best from Hollywood now in memory space. Thank you so much.
Okay, we can take let's say like 4 questions. We are like tight on time, but we'll have another like a bigger Q&A afterwards. So if you have any questions to Alex, in particular to the structured memory.
If you just go back to that slide where you have all of the latency and performance metrics, the percentages. So your latency on xmemory is 9 minutes, 9 minutes per run. Can you talk me through what that 9 minutes entails, given that the data should already be structured, right?
So basically, it's 9 minutes in synchronous mode when you try to write and wait for the system to extract and update information in relational database. You don't have to, because we have async writes, and very rarely your agent needs to read information right after it writes it. In most cases, it just needs to dump and move on. And this is one of the advantages of using xmemory instead of trying to implement it yourself. It's just we offload you from this asynchronous writes as well. In the synchronous regime, it's kind of, I don't know, seconds.
Any more questions?
Hi, can you talk more about governance and how xmemory is one of the only ones that's on that part of the graph?
Yeah, I think it's someone asked me today, like, what's happening in memory space. I think two things happening. One is token consumption is becoming a good topic to discuss with everyone, and second one is observability and governance. I think especially in enterprise, if you have structure, you can apply a lot of governance tools. You can do proper role-based access control. You can mark some fields and throw some columns in your database read-only for some roles of agents. So one agent is able to write and another one is able to read only. They might be able to write but not read, which is useful sometimes in some enterprise regulated kind of areas. So governance is all about being able to granularly control what data is exposed and written in the database. If you have based memory, it's impossible, because what you would need, and a lot of security companies on the market right now doing, is they say, hey, we have basically LLM as a judge, being a proxy for all the memory requests and judging whether it's safe or not to write, and they make mistakes. If you worked with the LLM as a judge, anyone in this room, it's not reliable, equally non-reliable as the memory solution. So yeah, real governance and real observability, I think, is a big topic, and without structure, you cannot achieve that.
Hi, thank you. You briefly touched upon graphs earlier. When you made a choice for Postgres as a backend, can you contrast that with your thinking of having a relational database as a backend versus a graph database? That's question number one. And number two is this going to some sort of a knowledge base eventually as well? Let's say your system is in prod for a year. The memory that gets accumulated over the year, can it be stored in something of a knowledge base that is a little more durable as well?
So I get the first question. I'm not sure I get the second one, but I'll try to answer. So the first one is graph versus relational. As I say, you can store any graph data set in relational database, but you cannot store any relational data set in a graph database. Why? Is because relations might be very different, constraints might be very different. You might have a lot of different complex keys in your schema. You have types of fields. You have a lot of benefits of relational databases that you don't get in graph. I know why graph appeared in memory spaces, because it's easier to extract and let LLM decide what is a node and what is a relation. And it was started as like a way to store temporal data, because it wasn't text storage. But now we think about more complex objects, as I said, with constraints, with keys and types and fields, which require more tools, and relational database simply supports more tools. And also what I like about this is that we're kind of getting back to raw engineering with this, because we have more control and more tools, and we bring the traditional kind of data engineering into AI space and bridging this gap. So yeah, I think it's just a natural evolution from text to graph and then to more structured storage. The second question was about the knowledge base. I think one of the things that compaction or compression is doing is it's losing the older the memory is, the more chance it's going to get lost in compaction over time. And there are a lot of memory solutions that are inspired by how our brain works. which is nice, but I wouldn't trust my brain to hold all the memories. That's why I have notes. That's why I have banking application for my transactions. I don't remember all the transactions and I don't need to. So as much as I like those inspirations, I don't like some information being inspired by how my brain forgets information. So the advantage of having structure and the advantage of having relational databases, the backend, you can query as long in the past as you like, and it's going to be as reliable as if it was written yesterday. So there is no such thing as kind of context drift or compaction issues here, because we don't do any compaction. If you have a fact about your, I don't know, salary that you disclosed in your chats with your financial agent, we're going to remember that forever until you decide to update this information. That's it. We're never going to get lost.
Thanks. And I'll close the Q&A with my own question, kind of using the privilege of being a host. So I kind of want to add up a little bit on this, like graph structure versus the schematic structure. What I worked with a graph database applying to LLM, and like what I discovered is that like as the graph grows, like the more you kind of ingest the complexity of obtaining data, like retrieving data from the graph, increase both in terms of the time complexity, but also in terms of collisions and ambiguities. If you allow the LLM itself to manage schema, and like graph, it's naturally schemaless. But in your case, it looks to me that there's structured memory where you allow the agent to define the schema. It kind of creates the quasi-graph in the sense that it also creates a flexible schema, which in turn opens the door for these collisions and ambiguities.
Correct. That's a fantastic question. That's why we only allow agents to define schema in the beginning, and then they start writing into the memory, and schema is constant. But then when we ask questions, it's not deciding the schema on the right path. It's deciding the schema on the read path. The moment you start asking questions that schema doesn't have the answers for, it starts proposing updates for schema based on questions, not based on information it's consuming. That's the key difference. Basically, graph is bloating because you try to store as much as you want, as much as you can, and you ask LLM to extract as many nodes and relations as it can. That's why it's bloating. We don't ask agents to extract all information we get in this write request. We try to analyze the questions, and if questions indicate that there is something missing, like an object or a field inside an object, then we propose evolution of the schema to someone. It can be a human, or if you allow it to work for long enough, it can polish this proposition and then do the update automatically. But this is not live yet. We are not doing any automated schema migrations at the moment. But the long-term path for us is like self-evolving relational memory, but based on questions, not the information is being ingested.
Awesome, thanks. Let's give a clap again for Alex. Awesome. It's really kind of opens a little bit like a mind about like what else is possible and what other solutions are kind of technically feasible, because it's kind of looks like we are all tend to kind of narrow down in our like few particular use cases that were proposed in the beginning. So thanks for kind of giving a little bit like a fresh view on that.